I'm now going to take a two-band FIR filter target, add a third quadrature band onto that, and roll the whole thing up towards Nyquist frequency to compensate for a zero-order hole such as you might find on a DAC. I'm going to start off with this two-band target right here, and I'm going to go and get myself now something which will allow me to carve out the third band. It's going to be at high frequency, so I'm going to go up here and get myself a high-pass filter. And in fact, these parameters suit me just very well here. I'm going to go from 0.4 to 0.42, and this will give me just that third area that I'm interested in. And so here I go. I go back to the target profile character, which at the moment has a calculator which has the old target on there. I want to make sure I preserve that one on A, so I'm going to get the FIR profile but keep it on B. This is going to be my chopper outer. And now of course I've got to get into the Hilbert transform business to make the whole thing quadrature. So I'll go to an even number of coefficients. You always want that with a Hilbert filter. And I'm going to go and get it. Of course it'll be a wideband Hilbert filter, and there it is. So I've now got this extra target, which I go back to the target profile calculator and get that one. Now I want to make sure, maybe put him on C this time. So I'm going to get the FIR profile, put it on C, and you can see since it's in red, this is imaginary, this is real. So it only remains for me to multiply these two, and that will chop out a high band bit on that. So it's going to be B dot C, memory store that in D, and there you go. So that's the bit that I'm going to want to add into the whole business. So I'm going to add this one to that one and get my total composite. So now I'm going to have A, which is that one up there, A plus my working one over here, which was D, and I'll put the whole lot in, let's say, C. Store that in C. Okay, so here you can see the different colors indicating which parts we've got. This is going to be our quadrature one. We're going to see how this works out. We're going to send that profile, which is on C, back to FIR, and there it is, setting to nonlinear phase because it doesn't recognize this as a linear phase situation. Well, that's the imaginary component of this magnitude. This is the real component just as before. Let's look at the whole lot. There it is with a bit of a gap out here, and so far we can't tell, but this design filter here has got these areas here in quadrature. We could see the full story on this perhaps by going up to CPIG and maybe going to see this magnitude, that is the linear phase free part, and just seeing how it toggles between. And sure enough, that's our filter, dB terms, all that sort of thing. Looks quite a reasonable filter, but of course the phase business is what's very funny about this one. You can see the phase changing pretty dramatically there. Perhaps I'll go for an unwrapped phase and see if that reveals any more. Yes, you can see the phase jumping around, which is due to that 90 degrees. Well, we could even look at the group delay if we should wish to. And there it is on quite a large scale. Maybe if we come down here to about 60 or so, we can see that it's trying to be quite flat at around 55, which of course is 102 minus 1 over 2, which is the amount of group delay possessed by this filter that we've designed. There's our coefficients. Well, it only remains now to take this whole business and in fact there's the target profile of it, and do a DAC roll-up. Well, let me clear the accumulator here. I've got a built-in command which will do this. Where is it? It is a DAC up. That's this one right here. I'm not going to apply it to A. I'm going to apply it to C because this is the target profile before the roll-up. I'm going to store this thing up here in, let's say, B. You can see now how it's rolling up. Ship that back, this B back there, and now you can see our filter right here where we're looking at it. I'm going to make sure I get rid of any imaginary component. Just look at the thing single-sidedly, and there it is. That's our gain of this filter. We've got DAC Rollup going all the way out to Nyquist, and we've done this by 102 samples, and we have a nice frequency sampling filter with that very strange dichotomy of phases as we go across the bands.